Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to discuss this chapter 8 in education 420, research methodology in education, and today we'll discuss sampling a population. First of all, let's define some important concepts. There are sampling, sample, population. So we are going to start with the sampling. Well, let's go to sample first. Sample, the representative selected from study for a study whose characteristics exemplified a larger group from which they were selected. So we have sample and we have population. The population is the larger group from which individuals are selected to participate in a study. So we have a large group called population and we have a smaller group called sample. So sample, the representative selected for study whose characteristics exemplify the larger group from which they were selected. Now we'll go to sampling. So there is a difference between sampling and sample. Sampling, it is the process of selecting number of individuals for a study in such a way that the individuals represent the larger group from which they were selecting. So this is sampling. Sampling, it's a process. Sample, representative, and population, the larger group from which the representatives or individuals are selected to participate in the study. Now, what is the purpose for sampling? It's collecting data about the population in order to make an inference that can be generalized to the population. Now, let's have a closer look about this. Suppose that this is the researcher and he wants to conduct a research or a study, and the large group is population. So the population is the large group. Now we said this researcher he couldn't apply or conduct a research on the whole population, so he's going to pick up or select a sample. A sample, it is a smaller group. Now we said the smaller group, the sample should be unbiased and representative. Why? Because this researcher is going to collect data, analyze data, and from data analysis is going to come up with inference. Now, if the inference that the researcher has is coming from biased sample and not the representative sample, so this inference will not be generalizable. So this researcher wants to make sure that his sample is representative and unbiased. We're going to help this researcher in selecting his sample. First of all, say that there are bad ways to have sample and there are good ways. Let's start with bad ways. Well, this is our researcher and this is the population. These are the population. Now, as you see, the population circle is full of happy faces. Some of them are green, some of them are blue, and some of them are orange. And this is the researcher. The first bad way to select the sample is what is called convenience sample. Let me write this here. This is convenient sample. Convenience sample. Now, what do we mean by convenient sample? It is convenient. This means that it's very easy to select. Well, this is the researcher and he wants, let's say, a group of 12 members. So he's going to select those happy faces which are very close from him. So he's going to select this member as this until, let's say, that he needs 12. So this is now the number, I think, 12. So it's going to select these 12s and it's going to say this is our researcher. Well, this is the sample. He wants 12 and now he got a 12. But do you think that this sample is representative? This sample is unbiased? Of course not, because not everyone in the population has an equal opportunity, equal chance to be selected. So this is one of the very bad way in sampling. It is convenience. Well, just look at this sample. We have 12, six of them, 1, 2, 3, 4, 5, 6, 7, 8, 8 green, just three blue, and just one orange. Obviously, this approach or this method gives or results in biased sampling, and it's not representative. I have just one orange, three blue, and eight green. So this is the convenient sample. Okay, so let's go and ask from these happy faces to go back here. Now this is convenience, and we said it's a bad way in selecting the sample. Another bad way in selecting sample is voluntary response sample. For example, this is our, let me just write this, voluntary. Voluntary response sample. What does it mean, voluntary response sample? Now, the researcher put out a request for members of a population to join the sample, and people decide whether or not to be in the sample. Well, this is the researcher. He said, "Hi guys, I have a study, and I want you. This study, let's say, is about teaching methods, and I want you to participate in my study. You will find that some of the members of the population are interested in participating in the study, and some of them are not interested. So you will find that this person, for example, is interested. Another one here is interested. Another one here is interested. This person is also 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 interested. And that's 1, 2, 3, 4, 5, 6, 7. And let's say this person is also interested. So I need 8 persons, 8 members, and now I got them. Now, if you see that also, it is biased. I have here 1, 2, 3, 4, 5 green, 2 blue, and just 1 orange. So it is not representative. Again, as long as it's not representative, then the inference that the researcher will have or will come up from that analysis from this sample will not be generalizable. So this is the second way, the second bad method in sampling. So we discussed bad methods in sampling, and we are going to go now to good methods in sampling. Okay, so let's leave this slide and go to this slide. Now, suppose that I have 30 members. This is my population, and I want 10 members. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 3, it is 30. And I want to select 10 members. Well, the first good way to sample, it is the simple random sample. Simply, I'm just giving I have 30 members, and I want just to give them, all of them, numbers. So let's give them numbers. And suppose that I'm going to give this 1, and this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Well, the simplest simple random sampling is just having all these numbers, put them in a hat, and then every time you select randomly one number. Suppose that in the first one you selected 5, the second first trial you selected 5, then you selected 10, then 4, then 13, then 24, then 30, then 19, then 6, then 23, then 17. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are the numbers that you have, or the members that you have. Number 5, this is number 5. Number 10, this is number 10. Number 4, again, go back to number 4. This is number 4. Then number 13, this is number 13. Number 30, this is number 30. Number 19, and this is number 19. 6, go back to 6. This is 6. Then 23, this is 23. And finally, this is 17. And here we have 17. So as you see, we have 4, 5, 6, 10, we have 19, we have 13, and we have 23, we have 30. Okay, I have 30 members in my population and I have selected 10, so these are 10. Well, if you just take how many green, how many blue, how many orange, we have for green, orange, let's start with orange, we have 1, 2, 3. So 3 orange. Regarding blue, we have 1, 2, 3. Also 3. In green, we have 1, and we have 2. We have also 3 or 4. So as we see, approximately we have 3, 3, 4, which is fair. Well, another way to select sample, yes, we can keep them. Another way to select members in simple random sampling, we can use technology. How can we use technology? Well, simply, this is a simple program from Google. You can give the list number and the maximum number. So just provide him 30, and then I'll just let the computer select, let's say the first one, 20, the second one, 8, the third one, 9, 4, 13, then 8, 4, 3, 8, 13, 4, until I have 10 members. So this is the first good way to select the sample, which is a simple random sample. Okay, let's go to the second good way. Now, the second good way is called stratified random sample. Yeah, this is stratified random sample. What do you mean by stratified random sample? Well, we just collect or divide the population into groups, and each group is or has a certain characteristics. Now we have the 30 members, as you see, and go back to happy faces. Now some of them has green color, the other blue color, and the other orange color. So we can simply collect them into strata. So I'm going to collect orange, then this is the, I'm going to take those blue away from here and come up with just green. So as you see, now I have a green strata. Then I'll go to have these blue. Okay, and also I have blue here, another blue could be added here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and also how many? 3, 4, and 5, 6. 1, 2, 3, 4, and 4, 5, 6. And here 1, 2, 3, 4, 5, 6, 7, 8, 9. We have another one. So as you see, this is green strata, and this is blue strata, and this is orange strata. So we can add the name here. Stratified random sample. Stratified random sample. Okay, this is stratified random sample. As you see, we divided the population into groups. Each group has special characteristics. So now we have three groups: green, blue, and orange. Green strata, blue strata, and orange strata. And again, I want to, let's say, 12 members. So I select by simple random sampling 4 members from green, 4 members from blue, and 4 members from orange. And I can go back to, let's say this is just 10. And let's say start with now start. I'm going to take 3 here, and 8, 3, 9, 10, and 2. This is for green, and for blue I'm doing the same thing, and for the orange I'm doing also the same thing. So I can select this member in addition to those members to represent the green one, and also I can represent this these 4 members from the blue one, and from orange you can select all these by simple random. So as you see now, I have 12, and I have taken 4 members from each strata. This means that I have a representative unbiased sample, and I'll be happy with the inference, and I'm sure that the results that I'm going to have is generalizable. Okay, so this is strata random sampling. Strata random sampling. Now let's go to number 4, or number 3 actually. It's a cluster random sample. Cluster random sample. Let me just write here. Cluster random sample. Now, as you see, I go back to my population, the happy faces. Well, I have 3 rows, and I'm going to select or consider that each row represents a cluster. Each row represents a cluster. So this is cluster number 1, and this is a cluster number 2, and this is a cluster number 3. In each cluster, there are all different happy faces. So I have in each row the blue one, the green one, the orange one. So I'm going first to select one cluster randomly. Okay. Well, I can. This is a cluster. I'm sorry. No. This is a cluster. Well, I can select randomly one of these 3. I'm going to collect or to consider the first one is cluster number 1, and this is cluster number 2, and this is cluster number 3. By simple random sampling, you have, or you can select one cluster, and then consider that this cluster is the sample, and you conduct, or if you want to interview, then you can interview all members in each cluster. Well, we can think about stratified and cluster. Let's just think about we want to conduct